Okay, so the first property is called the product property. Okay, so the idea of these properties is it's going to allow us to expand and condense logs. Okay, so for example, if we have some log with the base of b, hi. Oh, there we go. Hi. So, oh, well, I was just trying to get your attention. Okay, so if we have two things that are being multiplied after the log, regardless of whatever the base is, okay, so the x and the y are both being multiplied, okay, the expanded version of this becomes the log base b of x plus the log base b of y. Okay, so left-hand side is condensed, and this right-hand is expanded. Okay, so the first thing they're going to have you do is go between expanded form and condensed form, back and forth. Okay, so if we have a product rule, guess what the other rule is? The second rule. The quotient rule. Quotient property. Okay, and that one says if I have a log of some base of x divided by y, anybody want to make an educated guess for what the expanded form would be?
X. Log base b of x log base b of y.
Close. Minus. Minus. So see how times was plus? So when you have division, you subtract the two logs. So it expands into two separate logs. Okay, the third property is called the power property. Okay, so the power property is if your log has an exponent. I'll use an n to represent my exponent. Okay, so the condensed form has an exponent. The expanded form pulls that exponent out and just simply puts it in the front. Okay, so it becomes n times the log base b of x. So it's not really super expanded, but technically is expanded. Okay. All right, so let's see, let's use a different color. Nope, that was not good. Okay, so the first thing that they do is it's very interesting, I think. Okay, so they give us this direction of express each logs in terms of a log of 2 and a log of 3. Okay, so it's going to give us some condensed form, and then we're going to expand it. So let's see, I'm going to start with hopefully semi-easy one. Okay, so this will be the condensed form of this. Okay, so if I was going to expand this, the first thing I have to do is I have to really look at the 9 and the 8. Okay, and say, how can you use 2s and 3s to get to a 9? So what's the same as 9? 3 times 3, or another way to say 3 times 3 would be 3 squared. Okay, so we could say this would be equivalent to 3 squared. Okay, how would you get an 8 by using 2s or 3s? But no 4s, you can't use a 4. 2 cubed, 2 times 2 times 2. 2 cubed. Okay, so now what I'm going to do is I'm going to use my property. Okay, what's happening between technically the 9 and the 8? They're dividing. Okay, so what property am I going to use? The quotient one. Okay, so if the two things are being divided, when I expand it, what is it going to say?
You have to use the power property too.
Yep, and I'm going to use that second. You're right.
So it's going to be, really done, it's going to be 2 log 3 minus 3 log 2.
Yes. Was everybody able to follow what he just did? 2 cubed. So because it's asking you to put it in terms of 2 and 3. So the idea is what's going to happen is they're going to say, okay, well, the log of 2 is equal to, I don't know, some number, whatever log of 2 is equal to, and then the log of 3 is equal to this, and then they're going to say, now you can't use your calculator and figure out what the log of 9 divided by the log of 8 is. Okay. So if I use the power property, yes? Are you going to ask me a question, or are you...
Yeah. Wouldn't we learn product property instead to expand that to log free and then that one
Yep. You could totally do the product. So then it would be the log of 3 plus the log of 3. So if you have a log of 3 plus a log of 3, how many logs of 3 do you have? 2 of them, right? So that becomes 2 logs of 3. So if you end up adding your like terms, it turns into the exact same thing. So you could technically do it that way, yes. Okay. So was everybody able to follow that, what I just did? Yeah, then you're done. Okay, let's try another one. This one will be a little bit harder. Let's try the log of 54. Okay, so how could you expand 54? Again, we're trying to make it into a log of 2 and a log of 3. So how 54 by only using 2 and 3? Okay, so that's the right start. So I'm going to write this over here, that 54 is equal to 9 times 6. And how can you multiply the 9 with just using 2's and 3's? It's 3 squared, right? So 3 squared. Whoops, I wrote 2. My bad. How did I do that? 6. Okay, and then how can you get 6? No, that's 4. 2 times 3 is 6. 2 times 3. So, since I have 3 squared times 3, that's really 3 cubed times 2, right? So 3 cubed times 2 makes 54. Everybody follow that? Okay. So now, if I'm going to expand this, what two properties am I going to use?
Power product.
Power and product. Okay. So, can I go do both of them at the same time? Immediately just put the exponent in front. Is everybody following that? So I have the 3 in the exponent, so it goes in front. So it becomes 3 logs of 3, and then since it's product rule, what's going to go in between the two logs? Plus the log of 2. Good there?
Since you only put the card,
Yep, you still have to have the 3 in front of the log because there'll be 3 of those. Oh, correct, right. Because there's only one of those. Because the exponent with the 2 is technically a 1. Only the 3 has an exponent of 3. Hmm? Exactly. Okay. let's see. Okay, so the second thing they do with this is they ask you to expand and condense these with variables. Okay, so I'm going to say, so we'll just say, example 3, we're going to have log of 12x to the 5th y to the negative 2. Okay, so if I'm going to expand this, first of all, how many logs am I going to have? There's going to be 3. Very good, okay? Because there are 3 values that are being multiplied. There's one for the 12, one for the x, and one for the y. Okay, so when I expand it, what is this going to become? The log of 12.
Would be 5 log 12x though.
Nope, because the 5 is only in the exponent of the x, not with the 12, right? Okay, so what's the second term?
5.
Okay, good, and I'm going to say plus log, 5 log of x. Okay, what about the third term? Okay, good. So you could say it either way. You could say plus negative, but we're taught to make it simple, right? So minus 2 log of y. So kind of an interesting thing on this example. If you were going to take that and condense it, what would the condensed version look like? So if I was condensing it. Close, but what would you do with the y piece? The y would be divided. Okay, so if you condensed it, it would be 12x to the 5th over y squared. Anything that is subtracted is put into the denominator. So the question is this piece equal to the original piece? It is. Those two are exactly equivalent. The only difference is the bottom one is actually more simplified. The top one was given in an unsimplified form. You should never leave something with a negative exponent. Okay, so those two versions are exactly equivalent. Let's do another one just to make sure we have this. How about we have the natural log of x squared divided by the square root of 4x plus 1. So I would say this is probably about as complicated as you might see. First question on this, how many logs am I going to have when I expand it? That's exactly right. Okay, there are only 2 logs when you expand this. There's one for the x, and there's one for the 4x plus 1. The 4x plus 1 is a quantity. It cannot be separated. Okay, so when I expand this, what is it going to look like? What's my first one going to be? Good. Minus. What did you say for the last part?
The natural log. Right.
Okay, so interesting thing about this question, if I have a square root, can I rewrite a square root as an exponent?
Yep.
Because that's the same as to the 1/2 power.
Yep.
So when I expand it, what's going to happen with that 1/2 power? Goes in front. There you go. So it goes to minus 1/2 natural logs of the quantity of 4x plus 1. Okay, so the 4x plus 1 cannot be separated. Must stay together. That's as far as you can go. That one makes sense? Okay, so let's go the other way. Let's do condensed. Condense. So, number 5. Let's say we have log base 2 of 4 plus log base 2 of x minus 5 log base 2 of y plus log base 2 of z. There we go, that's pretty cool. Okay, so condensing it, when I condense, how many logs do I have? 1, remember that? Okay, so I've seen this, the log, and then people will start to write the word log again. When you're condensing it, you only write the word log once. Okay, don't try to make more logs in there. Okay, so remember that we basically have a log of a fraction. Okay, so after this fraction, it basically has a top and a bottom. See the top? Numerator, denominator. Okay, with my 4, where is my 4 going to go? Goes on the top. How do you know it goes on the top?
It's not.
Okay, is it being added or is it being subtracted? It's technically being added. It's a positive log, so it goes on the top. Okay, remember that I could have written this top line in any different order. Addition and subtraction are cumulative. Okay, it doesn't matter the order. Okay, so don't think that it has to go in a specific order. Okay, on the second term with the x, where's the x going to go? Oh, it should be yes, thank you. You are right. Okay, so the x goes on the top. Okay, what about my y? Okay, and what exactly goes on the bottom with the y? Y to the 5th power, okay, and it goes on the bottom. And what about my z? Ooh, does the z go on the top or the bottom? The top. Goes on the top because it's being added. No. Even though you would have, so like for it to be on the bottom, it would have to be a minus.
If the second term is then you would be on the bottom.
Exactly. So if it was like this, then you would have the z on the bottom. Yep. Yes, Josiah? Yes, there is a way to change it, and that's actually going to be one of the things that I'm going to go over, how to change the base. But if it was written as a 3, you would just write it separately. You would write the base of 2 piece that can be condensed, and then plus a log base 3 of whatever else it was. Unless they specifically asked you to, like if it was a variable, you wouldn't be able to do much with it. What? Yeah, you're right. Okay, so the next thing that we're going to go over is the change of base formula. Actually, I don't think they do change the base in this section. I should double check that though. Okay, so the change of base is basically what I just showed you guys. Well, it's actually not what I just showed you, but I completely take that back. Never mind. Okay, so the change of base, it does allow you to change a base of something, but it also allows you to put it into any calculator that has an LOG on it. Okay, so if there wasn't that fancy trick with the Windows button on your calculator, you could still do a log in the calculator with the LOG. Okay, and the way it works is it's just simply the log of x divided by the log of b. Okay, so for example, I think I'm on number 6 maybe. If I have a log base 3 of 5, how could I type that into the calculator? Okay, so it would be the log of 5 divided by the log of 3. The base number will go on the bottom. Okay, so can somebody type that in and tell me what that is?
1.46.
1.46? 66666?
No, 4. Maybe just fraction.
Okay, give me 3 decimals.
5.
65?
465.
465. Okay, so that's going to be my rule for you guys. I want 3 decimal places on this. Okay. Alright, so. Is that everything?
I think it is.
I think it is too. Alright, so. They don't actually ask you to change the base, so I'm not going to go over that, how to do that unless it comes up. So, the assignment is on page 185. And you have 2 through 58 evens.
58.
Yep.
What?
These are quick problems.